Hello friends, welcome to Learner's Planet. Friends, this is our first session for sets. This is going to be the very first chapter in grade 11 and important also because the forthcoming chapters, functions, all of them will be functions, relations, all of them will be based on sets only. Okay, so just get ready with your paper and pen and let's begin the session. Friends, the theory of sets was developed by German mathematician George Cantor. Okay, and now what exactly a set is? A set is a well-defined collection of distinct objects, right? A well-defined collection, that's actually important. A well-defined collection. And what exactly a well-defined collection? By a well-defined collection, we mean that there exists a rule with the help of which it is possible to tell whether a given object belongs or does not belong to a given collection. An object in sets may be anything, maybe numbers, people, mountains, a river, something like that, right? Now I take one example. Suppose I tell you set of natural numbers, right? Set of natural number. Now that is a well-defined collection of numbers. Now what is the definition of a natural number? The number should be whole number, right? The first thing, the number should be whole number and it should not be zero. So that is the definition of natural number, right? Now suppose we have number 5. Now I can clearly say that it belongs to natural number, right? That means the set of natural number is clearly a set because we have the collection of data which are well defined. They should not be negative numbers, they should not be fraction numbers, and none of them should be zero, right? So what is a well-defined collection? The collection of natural numbers, that is the whole numbers except zero. Okay, similarly we have other sets also. Suppose I talk about people, right? And maybe all the students in your class. Now there must be 20, 30, 40 students in your class, right? So the set of students of your class is a well-defined collection of distinct objects, right? Here we can say distinct people. Okay, suppose in your class maybe Ram is there, Sita is there, Bharat is there, maybe Vijay, Rajesh, various persons are there. All of them are distinct and you clearly can say this person belongs to our class. So that's a well-defined collection. Okay, so set is a well-defined collection of distinct objects. Now, what are elements of a set? The objects constituting the set are called elements of the set. It can also be referred as objects or members of a set. Suppose we talk about natural numbers. The natural number is a set is represented by n, right? And we represent the elements of set between two curly brackets. Okay, suppose I tell 1, 2, 3 and the series goes on till infinity. So 1, 2, 3, all the this numbers are actually elements of this set of natural numbers, right? That means 1 belongs to n, 2 belongs to n, 3 belongs to n, 45 belongs to n, and so on, right? Now if A is an element of set A, we say that A belongs to A. What I am telling, 1 belongs to n, right? Belongs to, that means the sign represents, that is one sort of E, and that represents the word belongs to. Okay, so 1 belongs to n, 2 belongs to n, something like that, right? So if A an element A belongs to set A, that means A, the element, belongs to set A, right? And if B does not belong, then you just put a cross sign over here, and B does not belong to A, right? Suppose I say -1 does not belong to n, right? Because in natural numbers we don't have -1. Okay, so you are clear what are elements of a set and what is a set. A set is well-defined collection of distinct objects, and elements of set are the members of this set. Okay, 5 belongs to n, 0 does not belong to n being a set of natural numbers. 25 belongs to p, p being a set of perfect square numbers. So 5 does not belong to p. 2 belongs to z, but 0.5 does not belong to z because z is the set of integers. Okay, so these are very small examples. You can make more examples. Various examples are there. Okay. Sets are usually denoted by capital letters A, B, C, X, Y, Z, etc. and the elements of sets are represented by small letters like A, B, C, X, Y, Z in lowercase, right? Sets are represented by uppercase and elements are represented by lowercase. Okay, so are you clear? Now when we discuss about a well-defined collection of distinct objects, we call it as a set. I gave you the example of some well-defined collection of distinct objects. One question may arise in your mind now, like I should put some examples where a collection of data is not a set. Suppose I tell you the maybe set of intelligent students in your class, a set of intelligent students in your class, or I can say a collection of intelligent students in your class. Right, now what is happening over here? What is the criteria for intelligence that you have not set over here? So it is not a meaningful collection, or we can say a well-defined collection of students, right? So it cannot be called as a set. Suppose you set a criteria like the students who score above 60% or maybe above 80% in first unit, right? More than 80% in first test. So if you call them intelligent, then you can make a set, right? Because you just collect all the students, just see their report card. If whoever is scoring more than 80%, they will come into this set. They will be the element of this set, that the set of intelligent student. But unless until there is a criteria, you cannot say the set of the collection of intelligent students to be a set. Okay, so you have to be very clear about it. Or maybe I can put up more examples. Most beautiful, beautiful ladies in or beautiful actresses in Bollywood, right? Now again, there is no criteria for beauty, right? Maybe you say fair color, maybe you say tall, maybe you say big eyes or whatever, but there is no specific criteria. If you set up a criteria that the actresses who are more than 5.5 inches are called beautiful, then you can collect some of the actresses, a group of actresses, and you can list their name who are more than 5.5, and then you can make a like a well-defined collection of all these actresses. Okay, but unless until no criteria is, unless until there is a criteria, you cannot make a set. Okay, it's a well-defined collection of distinct object is called a set. The very important thing is well-defined collection. Right, there should be some criteria. Now how do we represent a set? A set is often described in following two ways. One is the Rooster method or listing method, and in this method a set is described by listing elements separated by commas with brackets. These curly brackets are used. Right, say first 3 prime numbers, so that is 2, 3, 5. So this is the set of first 3 prime numbers, or we can say first 3 prime numbers. And if we want the prime numbers less than 10, so we can include 2, 3, 5 and 7, right? So this is a set, and this is a Rooster method to present the set. Okay, the order in which elements are written in a set makes no difference, right? Maybe you write 2, 3, 5, 7, maybe you write 3, 2, 5, 7, 7, 5, 3, 2. Any order can be there. There should not be repetition of the elements, and obviously order doesn't matter. Okay, next, the set of even natural numbers, that's 2, 4, 6. Here the dots stand for so on, right? Because you cannot list all the even numbers, even natural numbers over here, right? So what you do, if it is an infinite set, you just put dot 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 dot, or maybe a very big set, then you put dot dot dot, right? The set of vowels of English alphabets may be described as A, E, I, O, U. Since there are just 5 elements, you can write all the elements over here. So this is what the Rooster method or listing method of representation of a set. Next is set builder method or rule method. In this method, a set is described by a characterizing property px of its element x. In such a case, set is described x such that px holds or px holds, right? The set of all x such that px holds. Okay, the symbol or this symbol is read as such that. Okay, suppose we take up examples over here. X such that x इस तरह से है, sorry for Hindi, x such that x is a natural numbers and x is equal to 2n, right, where n belongs to n. So this n is actually what? It's a natural number, right? N belongs to n. This n is an element of the set of a natural number, and this x, what is the definition of this x? That is 2 of n. So whatever the value of n is there, suppose n may be 1, 2, 3, 4. So x will be 2, 4, 6, 8. Right? So this is the method, or we can say set builder method or rule method. Right? So x is a natural numbers and x is equal to 2n. Right? So if we wish to describe x, what it will be? 2, 4, 6, 8. And so on, right? So this is how we presented x in Rooster method, and this is the way we present the x, this set in set builder method. Okay, so you can present it like this, or you can present it like this. X belongs to n, x such that x belongs to n, and x is equal to 2n, where n belongs to n, right? This n is an element of natural numbers. Right. Similarly, the set A 0, 1, 4, 9, 6, and these are nothing but the square of the natural numbers, whole numbers, and can be written as A is equal to x square, and x belongs to z, right? So z is what? The set of integers. Okay, suppose you take -1, then also square will be 1. If you take -2, then also square will be 4. So square of -2 and 2, both of them will be 4. Okay, so this is the Rooster method, and this is the set builder method. Okay, now let's see types of sets. The first is empty set. Empty set, that means there are no elements in the given set, right? So a set which does not contain any element is called an empty set, null set, or void set. It is represented as, this is actually phi, or this is like there is no element between these two brackets. Okay, but this is wrong, right? This is not empty set. Between these two brackets, if anything comes out, then it is not an empty set, right? So generally students make this mistake. They write phi between these two brackets. So this is actually wrong representation. It is not empty set, because here in this case phi is an element of this set. Okay, so this is not empty set. So if you wish to represent an empty set, it should be phi, or there should not be anything between these two signs, these two curly brackets. Okay, now let us consider the set A, x such that x is a man living on the moon, right? Now A is a set that here x is an element and x is living on the moon. Now obviously there are no person on the moon, right? So A is an empty set. Okay, because there are no elements in A. And why there are no elements in A? Because there is nobody who is living, human being who is living on moon, right? Similarly, x such that x is a natural numbers and x is between 7 to 8. Now 7 and 8 are consecutive natural numbers. So obviously between these two there is no natural numbers, right? So in this case A is an empty set, because you don't have any number between 7 and 8 which is a natural number. Right? If instead of 8 it is 9 there, then we just have one element, that is 8. Okay, so but in this case between 7 to 8 there is no natural numbers, that means A is an empty set. Similarly, x such that x is a number, x is not equal to x, right? Now every number is equal to itself, right? So B will be an empty set, because no number is there which is not equal to itself. Therefore, A is an empty set. Okay. Suppose I tell you, and maybe a set of prime numbers, a set of even prime numbers more than 10. a set of even prime numbers more than 10. Now obviously more than 10 there are no even prime numbers. That is just one prime, there is just one prime number, that is 2, and that is actually less than 10, right? So a set of prime numbers more than 10 will be a null set, or we can say empty set. Okay, if there are no elements in any set, then it is known to be an empty set. Now as I told you, if there is something between these two signs, these brackets, then it is not an empty set, because there is one element and this element is actually 0, right? I'd give you the example of 5. So there is, if it is like this, then it is not an empty set because there is one element 5, and that's why it is not an empty set. So you should be clear about it. Now next is, what is a singleton set? A set consisting of a single element is called a singleton set. We can take some examples. There is 0, 5, -7, only one element in this set, one element in this set, one element in this set. So these are known to be singleton sets. Examples, we can say x such that x plus 6 is 0. Now there is one value of x which is added to 6 and produce the answer as 0. That is -6 only, right? So this is a singleton set. Okay, the only value of x that will satisfy this relation is x is equal to -6. The set, that's one element in this set, so that's a singleton set. Okay. Next is finite set. A set which is empty or consists of a definite number of elements is called a finite set. And what is cardinal number of a finite set? The number n in the above definition is called cardinal number, right? The number of element in a set is called the cardinal number, right? Or order of a finite set A. Now what is a finite set? Finite set, that means the elements can be counted in that particular set, right? I have example over here. The set 3, 4, 5, 6 is a finite set because we can count there are 1, 2, 3, 4 elements are there. So this set is, since the number of elements can be counted, this is a finite set. And what is the order of this set? That is 4, or we can say cardinal number is 4, right? The set of days in a week is a finite set because it contains a definite number of elements, that is 7 days, Monday, Tuesday up to Sunday, right? But if I talk about the set of natural numbers, so that's not a finite set. Why it is not a finite set? Because you don't know how many elements are there. So we call the set of natural numbers as infinite set. The set of solutions of x square is equal to 36 is a finite because there are just two elements, 6 and -6 in this set. So it is a finite set, and order of this set is 2, or we can say cardinal number is 2. An empty set which does not contain any element is also a finite set, right? So cardinal number will be 0 in that case. Infinite set, a set whose elements cannot be listed by natural numbers 1, 2, 3, and for any natural number n is called an infinite set, right? Or a set which has infinite number of elements is called an infinite set. The set of squares of natural numbers, because you don't know how many natural numbers are there, so obviously how many squares will be there, that also you cannot say. So this set is a set, but it is not finite, right? Cardinal number cannot be calculated. The set of concentric circles is an infinite set. Suppose you have a circle with this center, all of them are concentric, and you can draw as many circles as you want. So the set of concentric circles is an infinite set. You cannot say how many circles you will be able to draw. Gradually the radius will increase and you can draw more and more and more circles, right? The set of all points in a plane in an infinite set. For example, I have this plane over here. You can mark so many points, right? So how many points are there? Can you count? No, right? So set of all the points in a plane is an infinite set. So when you can count the number of elements, it is a finite set. When you cannot count the number of elements, that is then it is an infinite set. Now equivalent sets. Two finite sets A and B are equivalent if their cardinal numbers are same. Suppose NA is equal to NB. It represented as NA is equal to NB. That means number of elements in set A is equal to number of elements in set B, right? Here suppose A is ABC and B is 3, 4, 5. Now here we can see there are 3 elements, here also 3 elements. So number of elements in A is 3 and number of elements in B is 3. So A and B are known to be equivalent set. Okay, here also 1, 3, 5, 7, 12, 14, 16 elements, here are 4 and here also 4. So both of them are equivalent sets and their cardinal number is 4. Okay. Then we have equal sets. Two sets A and B are said to be equal if they have exactly the same elements. It is represented as A is equal to B, right? Otherwise the sets are said to be unequal and we write A is not equal to B, right? Order can be different, like here A, B, C, D are the elements of set A and here B set B, C, D, A, B, right? But elements are same. Here also A, B, C, D, here also A, B, C, D, right? 4 elements here, 4 elements here. So that's why A is equal to B, or we can say A and B are equal sets because each element of A is there in the set B. Similarly over here 2, 3, 5, 6 and 2, 3, 5, 6. So A is equal to B because each element of A is there in the set B and each element of set B is there in set A. Right? So equal sets and equivalent sets. Equivalent sets when the cardinal number is equal and equal sets when the elements are equal. Okay, be very clear about it. Now we see the next term, that is subset. What is a subset? Now listen to me carefully. A and B are two sets. If every element of A is an element of B, then A is called a subset of B and set B is called the superset of A. Now I take a very small simple example. I have the set of natural numbers and it is 1, 2, 3 till infinity. Then I have a set of whole numbers, that is 0, 1, 2, 3 till infinity. Now you can see every element of n is there in W. Right? The set of whole numbers. All the elements of n are there in the set of whole numbers. So n is actually subset of W. We can say n is subset of W. Why? Because all the elements of n are there in W. But W is not subset of n. Why? Because there is an element in W which is not there in n. Right? We have one element 0 which is there in W and it is not there in the set of natural numbers. So n is subset of W but W is not subset of n. Okay, and here we can say W is superset of n. Similarly n is subset of W and W is subset of Z. In Z what we have? The negative numbers -3, -2, -1, 0, 1, 2, 3. Okay, and we have 0 also, we have positive numbers also, right? So Z is the superset of W and N, both of them, right? So W is subset of Z, N is subset of W and W is subset of Z, and similarly if we move ahead, Z will be a subset of rational numbers, that is Q, and Q will be subset of real numbers, that is R, right? N is subset of W, W is subset of Z, Z is subset of Q, that is rational numbers, and Q is subset of R, right? So this is the superset. All the elements of N are there in the W, all the elements of W are there in the Z, all the elements of Z are there in the Q, and all the elements of Q are there in R, right? So real numbers, rational numbers, integers, whole numbers and natural numbers. Okay? Examples, we take more examples. Consider the sets A and B where A denotes the set of all students in a class. B denotes the set of all the students in a school, right? So we observe that every element of A is also an element of B, right? Suppose you study in grade 11 and there are 40 students in your class, right? So what is the set of cardinal number of grade 11 set is 40, right? 1, 2, 3, 4 till 40. Right? And if you talk about the set of students in your school, then all the grade 11 students will be part of the school also, right? So the set of school also. Okay, so grade 11 is subset of school. Okay, similarly grade 10 is also subset, grade 1, grade 2, grade 3, all of them are subsets of schools, students in this school. Okay, so the set of students in your school is the superset of all these sets. Okay, so that's very simple. Then we have one more example, 2, 4, 6, 8. It is a set of even numbers and it is a set of all the natural numbers. So obviously all the even numbers will be there in the set of natural numbers. So A is subset of B. Okay, but there are extra elements in B, right? But all the elements of A are there in the set B. Okay, so A is subset of B. If there exists even a single element in A which is not in B, then A is not subset. As I have mentioned over here, N is subset of W, but W is not subset of N because there is a single just one element, 0 is there, which is element of set W, but it is not element of set N. Right? So W is not subset of N, but N is subset of W. Okay? Now just now we discussed subset. Now there is another term, proper subset. If A is subset of B and A is not equal to B, then A is called a proper subset of B, and it's written as A is subset of B. Okay, now what is the difference between a subset and a proper subset? See, every set is a subset of itself, right? Suppose the set N is there 1, 2, 3 till infinity, and the other set N is there 1, 2, 3 till infinity. So all the elements of this set are there in this set. Okay, so N is subset of N because all the elements of this set are there in this set and all the elements of this set are there in this set. Okay, so N is subset of N. But what is the proper subset? So in case of proper subset, there are extra elements in the superset. Okay, so as I give you the example of W. So W is actually master set, and we can say N is proper subset of W. Right? Because all the elements of N are there in W, but there is one element in W which is not there in N. Right? So N is proper subset of W. Okay. For examples, and the null set phi is subset of every set, and every set is subset of itself, that I mentioned over here. N is subset of N, N is subset of N, but N is proper subset of W. Okay, because there are extra elements in W which are not there in N. So suppose A is 1, 2, right? So all the elements of A, if we take separately, that's phi is the null set, then 1, 2 and 1, 2. All of these are subsets. Okay, and out of these, phi, 1 and 2 are proper subsets. Okay, set of natural number is a proper subset of set of whole numbers, which I have shown you over here. Okay, phi has no proper subset. Every set is a subset of itself. The empty set is subset of every set. Okay, so the theory of proper subset and subset must be clear in your mind now. Now, what are the total number of subsets for a given set? Number of subsets for a given set are equal to 2 raised to n, where n is the number of elements. Suppose I have a set with 2 elements 1, 2. So how many subsets I'll be getting? 2 raised to n. Here n is equal to 2. So 2 raised to 2, that is 4. So how many subsets will be there? 4. The first is 5, then 1, then 2, and then 1 and 2. So these are the 4 subsets. Okay, so if there are 3 elements, you have to write 2 raised to 3, and that's 8. There will be 8 subsets. Okay, so that's pretty easy. So I hope you are clear with the basic definition, basic terminologies related to set. What is a set, what not is a set, and what is empty set, equivalent set, equal set, singleton sets, proper set, subsets. Okay, in the next session we'll be taking some questions based on sets. Do revise this session, and I'll see you in the next session once again. Bye bye.